Hi, everyone, and welcome to the second episode of Building SaaS on AWS. My name is Gunnar Grosch, and I am a developer advocate at AWS. And if you are building or planning to build a SaaS product, this is the show for you. So on the previous episode, I was joined by Ranjit Ramand, and we had a deep dive on architecting multi-tenant SaaS on Amazon EKS. So to even things out a bit, this episode will dive deep on architecting a serverless SaaS solution. And to do that, I am joined today by Ujwal and Anubhav from the AWS SaaS Factory team. Welcome to the show, both of you.
Hey, thank you.
All right, so let's do the traditional introductions. Let's start with Ujwal. Tell people a bit about yourself.
Yep. Hi, everyone. I'm Ujwal Bukka. I'm a partner solution architect with AWS SaaS Factory team. I am the part of the team where myself and Anubhav developed this reference solution, which we are excited to present today.
Hello, everyone. This is Anubhav, and I'm working here at AWS since last couple of years now. And as Ujwal mentioned, I'm also part of the team called as SaaS Factory. And just maybe a quick introduction about our team. So we are part of AWS Partner Network, and we help our partners who are building SaaS solutions on AWS. We work with them very closely, both on technical and business front. In fact, working with these customers, we heard a lot of feedback around, how to build serverless, how to use serverless technologies to build SaaS solutions, and that's where this whole concept of serverless SaaS reference solution came into existence. So nice to meet you. Thank you so much.
All right. So if you didn't catch the previous episode, this show is supposed to be as interactive as possible. So if you're watching and you have any questions along the way, feel free to just post your message in the chat, and we'll try to get my expert guests to answer your questions. So if you're joining us right now, please post something in the chat, so make sure that everything works as intended. All right, so let's start things out then. I think we need to first ask the question, why do we want to build a serverless SaaS solution?
So so let me briefly introduce about the key features of serverless, and then we'll dive into your question. So with the serverless, basically enables you to build agile applications so that you can innovate and respond to the changes faster. And with serverless, you don't need to worry about the management tasks such as capacity provisioning and patching. And with the serverless services come along, they come with automatic scaling and built-in high availability, and also they based upon the billing model is a pay-for-value billing model. So the key features I'm trying to point out here is you get better agility and less operational footprint, so better operational efficiency and better cost optimization. With these features, it lets you concentrate more on innovating your own product rather than maintaining time or spending time on the operational bits of it. These key features are very much useful or needed when you're building a SaaS solution, because in SaaS, you need to adapt to the market changes faster. Having agile application definitely helps. And also in a SaaS solution or in a SaaS product, the activity of the tenants are always be changing, and the way they are consuming the resources is also always changing. And it will be a challenge for the SaaS architects to build an architecture which closely follows this tenant activity. And the activity the architecture is such a way that it provisions the resources effectively and efficiently. With serverless taking over the scaling and also management of the infrastructure definitely helps in this area. And also it also reduces the burden of management. So hence, and also with all these features, you get more time spent on innovating your own product rather than maintaining it. So with all this, serverless is definitely compelling to build SaaS solutions.
Yeah, I would just maybe add a couple of sentences. Like the SaaS providers need to go to the market as soon as possible with their first MVP released, right? They need to focus on their IP rather than managing servers and everything. So with serverless, they can more focus on the IP on their proprietary software as such, rather than spending time managing scaling up and down. And so serverless take away that headache from them, I would say.
Yeah, so serverless is definitely a good choice for building something like a SaaS product. for sure, given that the scaling, for instance, is something that, well, you want your SaaS product to scale with the number of tenants you have on board. So let's just mention that we're going to dive quite deep into the architecture, but to start things out, let's talk a bit about the serverless SaaS reference architecture. What are some of the best practices that you've implemented into this architecture?
Right. So there are, if you look at, there are various SaaS best practices when you are trying to provision different tenants or managing the tenants, such as, like, for example, you can provision a tenant in such a way that they can use the shared resources. It's called pool model. Or you can provision the resources for the tenants in such a way that only you can provision a resource for only just for that particular tenant. It's called silo model. Whether you're provisioning the resources in the pool model or the silo model, there are various best practices around how you implement onboarding, how you implement authorization and authentication, and how you implement tenant isolation and data partitioning. And also there are, there's some good practices around how you need to lay out your services. Like, for example, you can have a bunch of shared services which are used across the tenants, such as tenant management service, user management service, primarily used when you're trying to onboard a tenant. And you'll have a bunch of services specific to your application. It's called application services. So what we did in the reference architecture is try to bring all these concepts into a working unit so that the consumer of this service can, to play with it, understand it, and take it further based on their needs. We use most of the AWS services to build serverless services to build this reference architecture. To name a few, we used Cognito, Amazon Cognito, Amazon API Gateway, AWS Lambda, and Amazon DynamoDB, and AWS Code Pipeline on Amazon CloudWatch.
Yeah, and just to maybe add, Ujwal, like we use SAM and CDK for the deployment bits of it. So one thing which sometimes people kind of ignore is the operational excellence that's required in a SaaS platform, right? You need to be able to apply releases with zero downtime, I would say. Like you have thousands of tenants, like the old concept of on-premise solution upgrade over the weekend doesn't really apply in a SaaS solution, I would say. So you need to be very much agile. So we also have covered some CI/CD best practices and how to apply a single build across those multiple environments, as Ujwal mentioned in this application.
And also, I also would like to point. So I also would like to point out, the notion of microservices or the way we implemented the microservices in serverless SaaS. So basically, the microservice boundary in the serverless SaaS is a API gateway backed up with a couple Lambda functions. Like, for example, if you take an order service, we created a Lambda function for create order, update order, or delete order. And these functions all together work on a similar set of a data set, so we can logically group them together. There is a huge advantage in decomposing your service into smaller bits, because if something fails, the impact of that failure is very less. And this is a huge advantage in an environment where your tenants are sharing your resources.
So I think let's start by looking at the repository for this serverless reference architecture, and let's take it step by step there to dive deep into each part of the reference architecture. So bring your screen up, Ujwal.
Sure, let me maximize it here. So yeah, so this is the GitHub repo of serverless SaaS reference architecture. So before you start playing with this reference architecture, please do run through these prerequisites, otherwise you'll run into some weird issues. The way you would kickstart this reference architecture is by following these instructions here. So as a part of these instructions, what you're basically doing is you're running a deployment script, which is in here. This deployment, before we look into this deployment script, let me show you a few other things here. So there is a bootstrap template.yaml. It's nothing but a SAM template, and this SAM template basically provisions the baseline infrastructure which is required for this reference architecture. As a part of this baseline infrastructure, it provisions a bunch of shared services which I mentioned earlier, such as tenant management service, user management service, tenant provisioning service, and it also provisions an API gateway to expose these services. And there are 3 UIs which we used in this reference architecture. And so this reference, this particular template provisions 3 S3 buckets and 3 CloudFront distributions to host the 3 UIs. And finally, it provisions a Cognito user pool for pool tenants and a Cognito user pool for operational users, such as SaaS admins. There is also another template called Tenant template. Again, this is a SAM template which provisions the infrastructure required for a particular tenant. So as a part of this template, we are provisioning a couple of services called order service and product service, which are application services which loosely mimics an e-commerce application. It also provisions an API gateway and DynamoDB tables, which are required for this particular service. And there is also a CI/CD pipeline which we built using CDK, which takes care of provisioning the tenant template.yaml, which we just saw. Basically, provisions the tenant infrastructure. Now let's look at the deployment script. So as a part of this deployment script, is basically what it does is it provisions bunch of resources in your AWS account. It starts off with creating a code commit repo and pushes your code into it. And then it builds and deploys the CI/CD pipeline, which we just saw. And then it builds and deploys a Bootstrap template, which provisions the baseline infrastructure. You need to pass in an email ID when you're provisioning your baseline infrastructure. This email ID would be configured as a SaaS admin. It's basically added to the user pool, and the user pool will send you the temporary credentials to log in. And then this script provisions or kicks off the CI/CD pipeline, which basically runs the tenant template. At this point, it is basically provisioning the resources required for the pooled tenants. And the rest of the script, what it is doing is basically building the code related to the 3 UIs and pushing that code into the S3 buckets. And to summarize all of these things, this is the high-level architecture diagram that we are provisioning. So basically, we are provisioning 3 UIs. One is a SaaS. You can see here on the far right, one is a SaaS admin, where a SaaS admin can manage the tenants. And the far left, there is another UI called landing or sign up page, where a client can come in and sign up themselves. And we are also provisioning a sample SaaS application. And there is an API gateway we are provisioning. And then there are a bunch of shared services, as I mentioned earlier. We are provisioning those things as a part of the baseline infrastructure. And also, we are provisioning a couple of the application services, order and product services. So that's
looking at the high-level architecture and comparing it to the first episode when we did one on Amazon EKS, it is very similar in the way the high-level architecture looks, but this one is instead based on a serverless architecture.
I do want to mention though one subtle difference and the strategy that we have adopted here. So, and as Ujwal mentioned initially, we have followed a tier-based architecture. So basically, what that means is the deployment. First of all, deployment.sh. That's a one single file. If you run, you just get the whole infrastructure deployed for you in your AWS account. So that's pretty straightforward, right? All you have to do is specify an email address, then you're good to go. Now, with this high-level architecture that you're seeing now, that is something we are calling it as baseline architecture. And what that means is this will install or deploy everything required for our pooled tenants. But then there, and Ujwal will walk through in more detail later. We have a concept of hybrid model here. So what that means is we are having certain like platinum tier tenants. So when they provision themselves or when they register themselves, we are actually provisioning a whole separate application services for them. So we will jump into that aspects in a little bit more detail, and that's one of the differences. Just wanted to highlight and want to make sure that customers understand that in some cases SaaS providers might have to support different variations of deployment depending upon their customer profile, right? And that's the idea we want to emphasize and highlight here. And I think that's something we want to go in more detail as well as we go along in this session today.
That's great. So I think maybe we should start from the beginning then. Let's say that we have this baseline infrastructure up and running now. The first step would then be to onboard a tenant.
Right. So yeah. So once you successfully provision this reference architecture, just want to point out a few things in the CloudFormation service. So what you'll see there is you'll see a bunch of stacks provision. So there will be a stack with the name of Serverless SaaS. This is basically the baseline infrastructure, the Bootstrap template which we just saw, and also it provisions a bunch of nested stacks. And also you'll see a stack with the name Serverless SaaS pipeline, which is basically the CI/CD pipeline. And you'll see a stack with the name as a stack pool. This is provisioning the pooled resources. For now, just ignore this particular stack. I'll get back to it. Just assume that you're not seeing that. As part of the baseline infrastructure, there are 3 UIs we have provisioned, and we'll look at the first UI. So this is the SaaS admin UI, and with this UI, a SaaS admin can manage the tenants, basically provision the tenants, and now look into the list of tenants. And now let's try to look at, obviously I need to log in. So when you run the deployment script, as I mentioned earlier, you need to send in an email ID. That email ID will be configured as SaaS admin, and I'll use those credentials now to log in. Okay, I'm logged in, and then now, so as of now, this is the tenants list of the tenants here, and I've pre-provisioned one tenant already, so we'll get to that tenant. Hold on to that. And the way we would provision a tenant or the onboard a tenant is basically filling up this form. Let's try to fill this form here. So we have a bunch of service plans. This is what Anubhav was previously hinting to. So basically, the service plans or the different tiers we have is basic, standard, premium, and platinum. So if you provision a tenant with basic, standard, or premium, so what they are basically provisioned as a pool tenants, where the tenants will be sharing the resources. And if you provision a tenant with the platinum tier, a separate set of infrastructure will be created for this particular tenant. It's called the silo model. And also, there is a varying level of performance between these service plans. What I mean by that is, like, for example, if the API gateway level, each of these service plan has a different set of usage plans, and hence has a different throttle limits and all that good stuff. So let's try to provision a basic tier tenant here. So now, as for the pool tenants, all the resources are already provisioned. What it does is now basically changing or updating the configuration to accommodate this particular tenant. So let's look at the AWS console and see what the things it has done. To start off with, and on the user pool, you can see that there is a pool tenant, and if you click on that pool tenant, there will be a new user added, or basically it added the tenant admin. And also it creates a group for this particular tenant and adds the tenant admin to that group. And also the other thing what it does is it captures this tenant information in a DynamoDB table, and we can look at that. So in the tenant details table, if I refresh here, we should see, yeah, so this is the one, the first tenant is the one which has got onboarded. Just ignore the second record, we'll get to it later. So that's the way you would there is another UI where it's called a landing page or sign up page where a tenant or a client would come in and can sign up. The way you would do again is a similar form, same form, and we'll try to onboard a second tenant. We'll use as a platinum tier as a service plan, and again, as I mentioned, with the platinum tier, a siloed resources will be created for this particular tenant. And after you click this particular event for the siloed or the platinum tier tenant, what happens is that it triggers a CI/CD pipeline. And usually the provisioning of resources for a particular tenant, for a platinum tier tenant, takes a couple of minutes. So what I did is, like, I pre-provisioned that particular tenant. So if you look at the CI/CD pipeline, it is already ran before. And what it does is it basically provisions the tenant template. This is what the template or the CloudFormation stack, you were looking into it before. So this is the stack for that platinum tier tenant, which has provisioned a bunch of resources. And we can look at those resources in here. To start off with, we can look at the user pool. There is a separate new user pool created just for this particular platinum tier tenant. And if you look at the users, again, it has created the tenant admin, and also it created the user groups. And if you look at the API gateway, it has created a new API gateway just for this particular platinum tier tenant. And if you look at the DynamoDB tables, and on here, you will see that there is a separate order table and a product table specifically for this particular tenant. Whereas the order pool and the product pool is for the pool tenants. Now what we'll try to look at the code and try to understand what are all the things happen when we try to onboard it.
So let's just step back there. The first example you gave was through the SaaS provider admin interface to onboard a tenant. Right. And you choose the pool model, but you could have chosen any model there as well, of course. Yep. And the other example was through a self-service portal, for instance, yep. the web page for that SaaS provider, whatever it is they are selling.
Yeah. So normally, think about it this way: like you are a tenant, you're coming to register yourself in your SaaS application. You need a way to just a open page without any authentication because you're not registered yet, right? So you need a way to go and just register yourself. So that's the registration page, the concept of registration page. But then normally SaaS administrators or SaaS providers need a way to manage their tenants. And what that means is they should be able to onboard new tenants if needed on behalf of a tenant, or update the tenant, or maybe just deactivate a tenant as well, right? So that SaaS administrator console is basically embodying that concept of a SaaS administrator doing certain things. And we are allowing both ways for a tenant registration and onboarding to happen.
Yep.
All right, go ahead, Ujwal.
Yeah, sure. So let me open my IDE here. So here you can see that the bunch of shared resources which I'm trying to point out here. So these are the shared resources which I was mentioning earlier, which will be used while onboarding a tenant. So to start off with, let me make it space here. Right. To start off with, this is a Python code. So when you onboard a tenant or click on that create button, this is the registration tenant is a method which gets called, and you can look at is that the first thing what we're checking here is what type of tier you are trying to onboard. And if it is a platinum tier tenant, you need to provision obviously the siloed resources. So we are creating an attribute with name as a dedicated tenancy as true. You'll see it down will how we are using this attribute to provision the resources. And again, I have mentioned that we are using different usage plans for different tiers. So we are trying to get the correct API key for that particular tenant here. That's all. That's what we are doing in these conditions. And then what happens is we are making a call to a method call which creates a tenant admin user. At this point, what we are doing is that we are making a call to another service called user management service. We'll look into that in a bit, which takes care of creating the admin user. And once it is successfully done, and then we are again making a call to another method called create tenant. At this point, it makes a call to another service called tenant management service, which captures the tenant information in the tenant details table. And then you can look at here is that we're checking if the dedicated tenancy is true. That means we're checking if you're onboarding a platinum tier tenant, then invoke a method to provision the tenant. So at this point, we are calling another service called tenant provisioning service, which kicks off the CI/CD pipeline, which we'll look at it in a bit here. So if you look at one of these methods here, what we are doing is basically we are making a HTTP call to the API gateway URLs of these services. The way we are restricting the interactions between the service-to-service calls is by IAM roles and using the resource policies of the API gateway. Now let's try to look at these individual services and try to see what we are doing in those methods. So as I mentioned earlier, this method we are calling another service called user management service. If I open that user management service, you can see that in this user management service, the first thing again we are doing is, if it is a dedicated tenancy, that means if you are provisioning a platinum tier tenant, we need to provision a separate set of user pool or a new user pool for them. That's what we are doing here. We are creating that user pool and creating the pool client and all that stuff. And if it is not in platinum tier tenant, we are just using the pooled tenant user pool ID and those configuration. And the rest of the code here is basically creating that user group and then creating the tenant admin user. And for the tenant management, and the next step which we did is that we're calling it create tenant, and for that this particular tenant management service is called. And if you look at the tenant management method, all it's doing here is basically capturing the tenant information. You can see this, all the tenant information in a tenant details table, so that it can be used later. And finally, if it is a dedicated tenancy, or if it is a platinum tier tenant, we invoke a provisioning method. So that at that point there is this, the tenant provisioning service is called, and the method it invokes is a provisioning tenant. What it does is a couple things. So basically, first it captures the stack name with the tenant ID in a tenant stack mapping table, and then invoke the CI/CD pipeline here. So this CI/CD pipeline looks at this tenant stack mapping table and get the list of tenants it needs to provision, and starts provisioning those services, provisioning those stacks, basically provisioning the CloudFormation stacks. That's a brief overview of what are all the things happens in the backend when we are trying to onboard a tenant.
Yeah. So and also, if there is any change in the code, the CI/CD pipeline will automatically update all the stacks based upon this configuration table now. So it's fully automated, and obviously, it makes sure that it will get the code from the code commit, build it, do whatever unit testing you need to do, and there might be other things that you might want to do, integration testing, some security testing, and then you deploy across all those tenant environments, basically.
Cool. So if you just joined us, this is the Building SaaS on AWS show. We are a bi-weekly show where we're diving deep on how to build SaaS on AWS. And this week, we are looking at the serverless SaaS reference architecture. So doing a deep dive on that. If you have any questions, just pop them in the chat and we'll do our best to answer those as well. One thing that we keep talking about when it comes to SaaS and multi-tenant SaaS is isolation. So can you show me a bit about how you're implementing authorization for tenant isolation use with the APIs?
Sure. Let me pull up a slide here. We'll explain the concept through the slide, and then we can go into the code and look at the things in more detail so that it will make sense. So let me pull this slide here. So here, so when a user comes in, he'll be redirected, depending upon the tenancy, he'll be redirected to the Cognito user pool. That's where he'll get authenticated. And then the Cognito user pool will generate the jar token. And with that request, with the jar token, the request would reach out to the API gateway. At the API gateway level, we are using, at the API gateway level, we are using Lambda authorizer. And the Lambda authorizer does a bunch of things. To start off with, it looks at the user role and then allows or disallows some of the roles. And also, as I mentioned earlier, at the API gateway level, we are using usage plans. So it brings in the correct API key based upon the tenant based upon the service plan you are using, and enforces the restrictions which are laid out in the usage plan. And then the next thing what it does is based upon the tenant and the role the tenant, the user has, what it does is basically it creates an IAM policy with the list of permissions, and also it adds a condition which has a tenant context in it. And then it takes this IAM policy and interacts with the STS to generate the scope credentials. This concept will be more clear when you look at the code in a bit here. But what it does is basically generates a scope credentials and passes this scope credentials to the downstream Lambda functions. So when the tenants are running in the pooled environment, as I mentioned earlier, they're sharing the resources and they'll be sharing these Lambda functions. In those cases, these scoped credentials will have access to, will have a narrowed scope only just for that particular tenant, so that these Lambda functions can use the scoped credentials to interact with their DynamoDB table in this case. So this is how we are implementing the tenant isolation in the pooled environment case. Whereas if you take the example of the sideload environment, where we would do is that we will provision a separate set of Lambda function, and it will have a separate execution role, and there are also a separate DynamoDB tables for that particular tenant, and this Lambda execution role will have the access to those specific tables. That's how we are doing the tenant isolation in the siloed environment. To back up a little bit here, so the concept which I explained, where we are generating the scoped credentials in the Lambda authorizer, is called dynamic policy generation. And if you want to know more about that, there is a blog post which is created by our colleague called Bill Tarr. Please refer to that blog post. We'll paste that link in the chat. So and the way, like, we have implemented this dynamic policy generation at the in the Lambda authorizer at the API gateway level. The other way you can implement this is you can push this dynamic generation policy concept into a microservice, and you can build that in a microservice. So in that case, depending upon your environment, depending upon your architecture, you might need to cache in the scope credentials, because every time the request comes in, you might need to regenerate it. So in order to avoid that, you might need to introduce caching. But the advantage of implementing that this dynamic policy generation in the API gateway level is you can use the caching provided by the API gateway. So inherently, API gateway provides the caching feature, where the time to live for the cache you can configure from 300 seconds to 3600 seconds. So the advantage of building this dynamic policy generation at the Lambda, using a Lambda authorizer at the API gateway level, is you get that caching out of the box. So, and again, depending upon your architecture or depending upon your needs, you can either build it here or you can build it in your downstream microservices. And
yeah, no, I just want to maybe add, like, this whole authentication authorization process, I would say, is at the core of this SaaS architecture. I mean, if you understand this, then you will probably be able to basically understand what's going on behind the scenes. And this also feeds, as Ujwal mentioned, into the tenant isolation bits as well. And maybe just one thing I want to point out is that number 2 blue dot on this architecture, when you get back the JOT token from Cognito, just want to mention that inside the JOT token, we have the tenant ID and the user role as part of custom claims. And that's what enable us and allow us to use and identify what tenant, or what tenant this user actually belongs to. And that is how we are able to now apply these authorization policies, apply the API keys, because now we know the tenant ID, and now we know that which API key belongs to this tenant ID. We know which user role this user belongs to. And also then, as Ujwal mentioned, we are able to leverage the tenant ID from the custom claim, obviously after we validate the JOT token, and then able to dynamically apply that to a policy template. And obviously we will look at the code as well, and then that enables us to generate a short-lived credential scoped for that tenant. And everything starts from the fact that we have that tenant ID and the user role inside the JOT token.
So, question from Toby in the chat. So API key in equal to API gateway API key?
No, we are talking about the API gateway API key functionality, actually, in this case. So we are using the usage plans and API keys, which comes as part of the API gateway. So one thing which might be worth noting here is that we are setting the API key inside the authorizer and not necessarily passing it from the UI, because in API gateway you can do it in both ways. The client can pass the API key from the client itself, but in our case, since we are dealing with the UI, not necessarily exposing this as APIs, we choose to look at the tenant ID, get from the tenant details what API key it belongs, it has, and then apply inside the authorizer. And then the authorizer policy, once it knows which API key is associated with this particular user, is able to apply that usage plan. And the way usage plan works is in two ways, right? It first of all, how many concurrent requests you can have at that time in a second, basically. And also it allows you to set some sort of quotas, like you can only have maybe 10,000 requests per day, as an example. And this is actually one of the best practices in a SaaS solution. You should be able to limit your tiers, your tenants. You should not let one tenant ruin the experience of other tenants, right? So because if you don't apply any throttling limits in your application, in architecture, it may very well so happen that one tenant can just keep bombarding your application and cause some sort of noisy neighbor issues for the other tenants.
So follow-up question from Toby then. Do you have to pass the access token and an API key?
So as I mentioned, the access token has the tenant ID in it, and we are using a tenant details table to fetch the API key and apply in the authorizer itself. I think it will be more clear when Ujwal, let's just pull up the code. It will be just much more clear rather than me just trying to explain.
Sure, yeah, that's what I was going to say. Yeah. So let's look at that authorizer, one of the authorizers here. So this is the authorizer which we are talking about. So what? So basically, it looks, the first thing what it is looking is depending upon the role. If it is a SaaS admin, the SaaS admin, as I said, it's created in a different user pool. So it's getting this user pool configuration. And if it is not, if it is the rest of the, for the rest of the things, what it is doing is it's fetching the details from the tenant details table where we're capturing the tenants. So if you look at those details here, what we are getting is the user pool ID, API client ID, and then the API key. The API key, the one which Anubhav was referring. So we got the API key from the tenant details table. And the next what it does is basically it has the user pool and that app client ID role. So obviously it tries to validate the jar token. And once the jar token is validated, what it does is basically checking the role to ensure that they have proper access to access this particular URLs, and does that check. And then the rest of the code here is what it is doing, the dynamic policy generation. So let's look at, so if you look at the line here, what it is doing is like passing the role, and based upon the role, it is generating the IAM policy. Let's look at what policy it generates. So let me go to this particular code here. So auth manager, get policy for user, and if it is any of the any of these users, but what it does is if you look at for the tenant, let's look at the tenant admin policy. So here it's generating a policy. This policy has is giving permissions to a bunch of tables. These permissions for these bunch of tables. And the thing, the interesting thing it is doing is that it's placing a condition here, basically injecting the tenant context, and the tenant context is nothing but the tenant ID. And what you're doing here is like basically you're giving access only to the data which are with the leading key of tenant ID. So when after the authorizer gives the scope credentials, and then when the Lambda in the pool tenant tries to access the DynamoDB table for its data, only the data of related to that particular tenant will be visible to that particular Lambda function. That's how you are narrowing the scope. And if I can go back here, I'll show you the rest of the steps, what's happening there. So you get this IAM policy and apply that IAM policy to a role, and then you interact with STS to generate the scoped credentials. And what we are doing is that we are creating a context which has these scoped credentials and the API key and all that stuff, and then setting the context to the response so that it will be sent to the downstream Lambda functions. And finally, the API key, we set this API key here. So as Anubhav was saying, what the approach which we took is where we have configured API gateway to look at the authorizer and validate the API keys. The way it does is basically you need to configure the API gateway to look at the authorizer, and you have to set this API key to this usage identifier key, and the API gateway takes care of the rest of the magic. As Anubhav was saying, the other approach is you can set the API gateway to look at the header for this API key. In that case, at the client level, you need to basically pass in the API key. And usually sometimes API key would be in the as a custom claims in the jar token. You have to crack open the jar token and send the API key. But in this case, you don't need to do that because we are using we are configuring the API gateway to look at the authorizer, and we are setting this header here. So that's how this thing happens here.
Right.
Yep.
So yeah, Anubhav, go ahead.
No, I was just this context object in itself is very interesting, right? And this is how we are basically passing the access keys and the secret key, basically the short-lived credentials, to the downstream Lambda functions, and also telling the Lambda function which tenant it belongs to. And I think, obviously we will look at the code for that Lambda function as well, how it's applying tenant isolation eventually. I mean, as I mentioned, it's really important to understand that this authorizer is playing multiple roles here. And the reason why we are choosing to generate this STS credential inside the authorizer, as Ujwal pointed out, is to take advantage of the caching behavior of the authorizer, which comes by default inside API gateway. But you can very well just choose to create this short-lived credential in your Lambda function as well if you want to.
Right, so this is Building SaaS on AWS. We're doing a walkthrough of the serverless SaaS reference architecture. And I think, can we perhaps have a look at how it's implemented in DynamoDB with pool and silo tenants?
Sure, yeah. So if we go to the AWS console and let's pull up DB. So as I mentioned earlier a little bit here, so for the pool tenants, what we are doing is we are creating a pooled table. That is for product service, there is a table called product pool, and the order table would be order pool. And for the each individual tenants, whereas a platinum tier tenant will have a separate set of tables created for these individual services. That is the order dash, and then the unique ID and the product dash. And the way we are storing this data in the DynamoDB table is basically we use the tenant ID and with a suffix. And you can once we try to provision some products, you will see the data here. But the important bits here is like the partition key here is basically the tenant ID with a suffix to it. The suffix is a random number, and the reason why we are doing that way is to avoid hard partitions, which might lead to the noisy neighbor conditions. And in order to know more about this concept, like now why we need to do it and how we need to do it, I would strongly recommend to look at the blog written by Anubhav and Todd. We'll paste that link in the chat. So yeah, Anubhav, feel free to chime in here.
Yeah, and it's hard to see because we don't have any data in this table right now. Unfortunately, maybe if you just post the link of the blog post, Gunnar, in the chat, we have screenshot which have the actual data, and the idea is that the shard ID basically means you have tenant ID and a business key, and not just only tenant ID into it, because then you can run into hot partition issues, because then you will have maybe thousands or millions of rows only for that one tenant, and there will be a sort key for sure to have that primary key, complete primary key in place. But we basically are sharding by tenant and a business key, and if you might have noticed that condition that we provided initially, it was not string equals, it was string like. So that means anything which contains or starts with the tenant ID, and there could be another business key after that. So there's a whole blog post which is something which I recommend that people go through and read through it for sure. And maybe, Ujwal, if you don't mind, can we also pull up the data access layer and just quickly look at that, what happens after you get those short-lived credentials, unless you plan to do that later.
Sure, we can show it right here now. So let me pull up. So if you look at we will take an example of an order service and application service. So
yeah,
do you want me to write? We'll go with the product service.
Yeah, product service data access layer.
Oh, okay, product service.
Yeah, and so just go to that get database. If you just go to the get DynamoDB method at the very end, get DynamoDB table actually.
Yeah.
Yeah. So I think maybe just one thing I want to show here is, if you might remember, in the authorizer we were passing the secret key and the access key, and if you notice here, the line number 157 to line number 161. So if you see that when we are creating the DynamoDB client, we are passing that access key and secret key we got from the authorizer. And this is how your tenant isolation is happening, by the way. So you were generating a short-lived credentials, but you pass that SGS credential to your Lambda function. And your Lambda function, when it creates the DynamoDB client, is now by virtue of those short-lived credentials only have access to those rows which belong to the tenant. And then if you look at that else block, which basically is like, if it is not a pool tenant, if it's just a silo tenant, we are not applying that. We are not using those STS credentials. And the reason being, as Ujwal pointed out, when you deploy those individual Lambda functions for the tenant, you are just applying, you're just mentioning the execution role of that Lambda function itself, that which table it has access to. Because we have separate tables for those silo tenants, so you don't really have to use shorted credentials there. You can just, in the execution role of the Lambda function itself, say that, okay, this Lambda function only have access to this particular table. So I just wanted to point that out as well.
So maybe to show some more details, maybe we should log into the actual SaaS application to see what happens when we use it and what happens in the DynamoDB tables, for instance.
Sure. So let me pull up the sample SaaS application. So yeah, this is a sample SaaS application. So I just want to point out one challenge with the sample SaaS application is whenever a user reaches whenever user access a sample SaaS application, you need to know the tenant the user belongs to, so that you can load the configuration related to that particular tenant. The configuration in here, what you're seeing, what you're talking here is basically you need to know which user pool the user belongs to, or the tenant or user pool of that particular tenant, and also so that you can authenticate that user against that user pool. And after that, you need to know which API gateway URL you need to send the request to. So there are a couple ways of doing this. The one approach you can take is using subdomains. That is, for example, if your domain name is example.com, you can, for each tenant, you can have a different subdomain like tenant1.example.com. And if the request comes from that particular subdomain, you can forward, or you can do the rest of the magic there. And the other approach
is what we saw in the previous episode with the Amazon EKS reference architecture.
The UI is exactly the same.
Yeah.
with the only difference that we ask for the tenant name while logging in. And in the EKS, they are using subdomain-based approach. Maybe just one quick caveat there, or maybe just highlighting that fact that there are a couple of ways you can identify or maybe pull up the configuration for that tenant. You can either use subdomain-based approach, or you can just ask for an email address or something, and that's how you identify which tenant is trying to log into the system, and then you can do the appropriate flow after that, basically.
Yeah, so as Anubhav was saying, we have implemented the second approach where we are asking the tenant some tenant information. Now, let's try to provide that information since we have onboarded one tenant, that is the first tenant. And when if you remember, when we onboarded this particular first tenant, we have given an email address, and that will be configured as a tenant admin. And let me pull that credentials in here. Give me a few seconds here.
Yeah, while Ujwal is doing that, post your questions in the chat. If we're not able to answer them live, we also have Bill in the chat who's answering questions I can see as well. So go ahead.
So since it is for the first time we are logging in, it is asking me to reset the password here. So that's what I'm doing. Yeah. So yeah, now that I'm authenticated, now let's try to provision some product service, some dummy products here. So one. So it has created the product, and similarly I can create some order.
And now, by the way, you can also see some data in the tables.
Yeah. So that's what. Yeah.
I might have missed that. Was this the pooled or the siloed?
The first tenant is the pooled because it's a basic tier tenant. So now we can look at the table, the pooled table, and look at that information. So since it is a pooled one, so since we have added a product, it has created the product information here, and then this is what we are referring to. The suffix it has a. Not sure you guys are seeing that, but let me see if I can click on the. This is a better view. I don't know. Yeah. So
yeah, we are just generating a very long tenant ID, UID for now. I mean, it doesn't have to be that way, but it just guarantees some uniqueness, though.
And it has a suffix in the end. That's the concept we were trying. Anubhav was explaining in detail before. So that, and then also the similar thing you'll see in the orders table, where we have created since we have created in the UI, we have created a record that will be in here. So yeah, that's how you on a sample SaaS application, try to show you that how you will do that. Let's do one thing here. We'll try to log out of this particular first tenant and try to log into the second tenant and see how it looks like. Basically, what you'll see is like there is there won't be a unique. There will be no any products and anything products or orders created there because it's a different tenant. And basically, point I'm trying to make here is that you'll have each tenant will have its own unique experience of SaaS application.
Right. Let's have a look at that then.
Yep.
And again,
yeah, and while Ujwal is just trying to log in, obviously we have separate API gateway for that tenant, right? So, so that's another, and that's one of the reasons why we are inputting the tenant name so that we can know which API gateway to call to or which user pool to authenticate against, because there's a separate user pool as well. And just want to point that out while Ujwal is trying to reset the password here. And one thing I also want to point out, the whole concept of this tenant admin and why we provision a tenant admin as part of the tenant provisioning process, because this tenant admin is now responsible for adding new users for that tenant or even managing that tenant in general.
So yeah, so
there's a question around, let's say, around the service quotas and 10,000 user groups is reached for pool tenants. What's the workaround to onboard new pool tenants?
Yeah, so then that's where we have this hybrid model. You can choose to have one user pool per tier if you want to. We just had one user pool for all the basic, standard, and premium tier, but you can always have separate user pools, and the way the solution has been architected, it's very convenient for you to have multiple user pools per tier, and also have one user pool per platinum per tier tenant. That would be the strategy there. Yeah.
And having separate user pools means that you're able to have, well, configure them each, the security settings, things like that for each.
Yeah, exactly. Yeah, I mean, you can also have different password policies or different reset policies and etc. Yeah.
All right, Ujwal.
Yeah, so as I was saying, you don't have any product, you don't see the products or orders which we created for the other tenant. So basically, each tenant will have its own unique experience of the SaaS solution. So that's what I was trying to show you here. Yeah.
All right. So if you were to create something now, it would then be stored in that specific tenant's DynamoDB table instead.
Yes. Oh yeah, we can.
So let's just do that to make sure that.
Sure, yeah. That's it, sure.
So we are approaching top of the hour, so we need to start wrapping up. A couple of questions. This reference architecture, it has a sample SaaS application, but how much work would it be to use the reference architecture with your own SaaS application? how separated is that application from the rest of the architecture?
Yeah, I mean, the whole architecture in itself is microservice based, right? So what I have seen personally, working with multiple customers and the way they are taking advantage of this reference architecture, they do one of two ways, right? The first way, our customers, what they're trying to do is they look at this architecture, they take some best practices, they take those concepts that we have applied and apply them in their own way in their own architecture. Or the second thing, what they do is they especially take out that shared services piece and the authorizer piece, right? Because that's the, I would say, meat of it. The shared services, how the registration process work, how the tenant management works, how the user management works, and the whole authorization piece where you are, authorizing and generating a tenant as short-lived credentials and applying dynamic policies, and the code in the data access layer that we saw, which enforces the tenant isolation. So that is what you really need from this architecture. Obviously, there are other things like CI/CD, and we haven't really talked about the concept of observability, which, by the way, we are making advantage of Lambda layers to generate metrics and logging as well, and that allows us to centralize, create separate libraries for basically metric management and logging, because we are making sure that the tenant context is applied when you're logging your logs into CloudWatch or when you're generating metrics as well.
I think we can have a separate episode just on observability and metrics and logging.
Exactly.
For sure. All right. So yeah, is that the tenant table we see right there now?
Yeah, the product table and the order table we just provisioned, so it has been made into the inclusion together. Successfully tested. Yeah.
Right. That's cool. So I think it's time to wrap things up. Just a couple of minutes to go. I leave it up to you to just give some last minute tips. What do you think the viewers should do based on what we've just seen?
Yeah, I mean, I would say that, feel free to jump in and try to onboard, try to run this thing and load into your account and play with it, so that you can get your hands basically dirty and understand the things and take it further based on your needs. And yeah, it is a GitHub repo, and you can post your questions and anything issues you see or anything. Feel free to suggest any ideas or the things which you plan to look for in this reference architecture. Yeah.
And please give us some feedback. I mean, we will be maybe prioritizing more and adding more features to this reference architecture based upon the feedback. There is obviously in GitHub, you can just open an issue and just ask for a feature. If you think that's something beneficial for you, we'll be definitely trying to prioritize that as soon as we can. And just gets your hand dirty, as Ujwal mentioned. The whole documentation itself, I would say it's very informative. Even if you just want to understand the concept of SaaS, if you just go through the documentation itself, it will be very informative and enlightening for you, I would say.
Very cool. So I think this hour just flashed by. It was very quick. We could probably spend several hours more going through this reference architecture, but I'm very happy to have you both on and to walk us through the reference architecture. I hope the viewers enjoyed it as well, and that they got at least a glimpse of what the reference architecture can do. So don't miss the show in 2 weeks. We are on every other Wednesday. So the next episode, let me just get that up. So the next episode is on, trying to find the date, September 8th, where we will be talking about AWS Private Link for SaaS and how to deliver SaaS through AWS Private Link.
Very interesting topic. Yeah,
that it is. So once again, thanks Anubhav, thanks Ujwal, thanks everyone for watching, and I hope to see you again in 2 weeks.
Thank you.
Bye-bye.
Okay, bye.